Hi, good evening everybody. So before I start, many thanks to Omri and Kyriakos for organizing tonight's meetup, and of course also many thanks to Uwe from Kavak to host us tonight here, and also to Frank. Thanks a lot for organizing. I'm really happy to be here tonight. So my name is Nick. I'm working for XAIN. XAIN, it says it right here, it stands for the Expandable AI Network. I'm doing business development, so this includes quite a lot of things, and I'm not going to spare too much time on talking about what I do, but rather about what we as XAIN do. So we do quite a lot of things, and before I jump into it, I'll give you a brief overview of what we're currently doing and where we have come from. So we originated from the Oxford University and Imperial College as a research project, where we initially looked into distributed intelligence. Distributed intelligence is a concept where I would try to let two entities, two edge devices, communicate with each other about things. So these things could be one car driving in the snowy mountains and one car driving in the crowded city, and the car from the city would drive to the snowy mountains, and there would be a need for the car which is currently driving in the snowy mountains to transfer the experience it has made in the mountains to the other car, so the other car could adapt. So while we were pursuing this, we quickly realized that we somehow have to find a solution for something which can be called access control, or an access control problem. So access control is a pretty basic concept, which is me unlocking my phone with my thumb. It is me sharing my Google Docs with Frank, and so on. So access control is in every part of our life, but current access control solutions are very limited, and this is why we realized that we have to look into some access control solutions a bit more. And we also realized that some DLT solutions might actually be very helpful to what we had in mind, because of providing consensus among the stakeholders, and also make sure that certain transactions and certain accesses have been granted. So we started off as a research project, but we didn't found until February last year in 2017. We quickly continued to do a couple of POCs, mostly in the area of consulting, and then we were participating in the Porsche Innovation Contest, which we were actually able to win. And based out of that success, we started the POC, Porsche Innovation Contest. So we started the POC with Porsche, where we built in a lightweight blockchain node in the car. I'm going to talk about it in a second. Now we are engaging with a couple of clients within POCs. Had our first funding round, and are now around 35 people, I think, mostly engineers. So our funding team is live. We've heard his name quite a lot of times already tonight. Then we have Michael, our CTO, and Felix, our CEO. Funny thing is, they didn't meet randomly. Who would have guessed? So Michael actually has been a professor in Imperial College, but now he reduced his professorship and is working full-time for XAIN as a CTO. And Live and Michael have met at Imperial College when Live was writing his PhD with Michael. And Live and Felix met at Daimler, so there is also the first connection to the automotive industry. So XAIN, as the name says, it says Expandable AI Network, and what XAIN in the end is about, it is to give you as private individuals, but also enterprises, the possibility to exchange data, resources, and knowledge. This sounds oddly strange, and I agree, and I think it's a concept we all have to wrap our mind around a bit, because I think I can somehow imagine how resource sharing looks like. I've been using Drive now, for example. I can also imagine how data sharing maybe looks like, because I've also used Google Drive before, but when it comes to sharing knowledge with someone else, which is not in the form of a wiki article, I think it's quite cryptic, but luckily we're going to talk about it. And then we have first initiator of some of our technology part. We see down here Frost. Frost is a domain-specific language we developed to solve the access control problem I was talking about in the beginning. So now comes a couple of slides which are giving an overview of the technical components we have been developing over the couple of the past weeks and months and years, actually. So Frost itself is, as I said, a domain-specific language. It allows you to create policies. Such a policy could state that I give someone else access to my data in a predefined time frame on a predefined date for a certain amount of money, and if you have 5 stars or 4 stars on Airbnb or somewhere else. So it's a really agnostic protocol which allows you to create such policies. And the beauty about this is that you can put as many conditions behind it as you want, and also you can delegate policies over multiple parties. So I could create a policy stating that Frank now is allowed to access one of my assets, and he could then pass on that policy to Thomas. And I would be aware of that, and I could also say, no, I'm not fine with that. But in general, I can provide transparency, and this is where our Frost technology is pretty superior to existing solutions. And this is becoming quite important for the scenarios we have in mind. So then we developed our own proof of kernel work, which is a consensus algorithm, which is based around the idea of proof of work, but it's a slimmed down version, which is made for IoT devices, a much more energy efficient version of proof of work, because you don't let all miners participate in the mining race, but rather select a committee before the actual mining begins, and then only the committee does the puzzle solving, which results in, of course, fewer nodes participating, but we also have some other security factors up front, which allow you to lower down the puzzle difficulty by quite a lot. So we, in the end, have really energy efficient consensus, which allows us to bring this to an IoT world. Next part we have, and this is where I want to maybe draw a small analogy. So we were perceiving that we were working quite some different levels, and this is why we drew an analogy to biology. So you can't read it, but I can read it out for you. So we have habitants, we have habitat, and we have biotopes. So I don't know who has studied biology. I haven't, but I found this quite appealing because it gives us a way to visualize what we're actually doing. And what we are right now doing as XAIN AG is we bring two enterprises together, form somehow a consortia with them, and give them the opportunity to exchange data, resources, knowledge, whatever, within that biotope. And we do that with a big data reference architecture we developed. It's not mandatory, but you can, of course, use it because we develop predefined APIs, and so it just smoothens out the process behind it. And to also bring this into the IoT world, into the world of hardware, we've developed embedded client. This is basically a result of the Porsche use case, where with the look and the hungry faces, I would say we'll skip that use case for now. I'm happy to talk about it later, but the general concept of the embedded client I'm still going to explain. So it is basically a compiler for the policies which can be created with Frost. So there is some complex architecture within what's going on, but what it's basically doing is it's checking if you as a requester to access a vehicle, for example, actually have the rights to do so if the policy has been broadcasted to the car prior. And this is what the embedded client does, and it can also be connected to some form of a DLT. And this is basically enabling us to hardware enforce policies in an IoT world. So here is an example of what we did with Infineon and how it worked here. So me as the car owner, I have a client app, which is basically me stating that I'm the owner of the car. I would broadcast a policy to a blockchain network. Now we have simulated this with proof of kernel work, so our own testnet. This policy would then be synchronized with my car, with the microcontroller on my car, and then if someone, whomever I wanted to give access to my car, would approach my car, then the policy would be checked, and if authenticated, then my friend, whoever that might be, has access to my car. And this brings us to a first a little more complex use case, and this is where I'm saying that the delegation part of things becomes actually quite important. So what we have here is me as the owner of some form of electric vehicle who is approaching a charging station. I want to charge my electric vehicle, and I'm going to pay money for electricity. So what is a possibility right now that I give general consent that my data can be sold, and for selling my data I receive a reduction of the costs for the charging process. And what's happening then is that whoever is buying my data, he has real-time data of me myself. So this is basically stating that Nick right now is, I don't know, what's the street called here? Heidenkampsweg. So Nick is right now at Heidenkampsweg, and I would get an advertisement to my cell phone stating, "Hey, Nick, come by the next Starbucks, get 10% off," and this would result in a reduction of my fees. So this, of course, hasn't to be with Starbucks. This could be with other companies as well. And of course, Starbucks purchase is not going to make up for the entire process of charging the vehicle, but it might come to a reduction if you talk about other vehicles or different brands who are trying to get you into their stores. And then I'm already at the topic of how can I provide access to knowledge. So access to knowledge is basically a concept we are also able to realize with the power of Frost, because Frost, in comparison to other access control protocols, doesn't give us only the possibility to access on a level like a reading level or a writing level, which are quite invasive, but also in a much slimmer version or a much slimmer level, which is a may train level. So this is centered around the idea that Google and another company called DeepMind were able to reduce the server cooling costs of Google by up to 40%. So what happened is that DeepMind was creating an AI which was training on the data sets of Google, which there are a tremendous lot because Google has a tremendous lot of server centers, and the AI was able to improve by really significantly fast, and in the end achieve this result. If I would, however, come to a company which is much smaller and has only poor server centers, then we most likely wouldn't see the same effect. So what we're trying to achieve here is to show that this power can also be brought to people who don't have incredible amounts of data at hand. And I think we all can imagine some scenarios where this can actually become important, and I think this is the first time that we can also see an analogy to the COBILITY consortia. This is basically an example of how we already did that, or are currently doing this. Not going to talk about it now, but I wanted to bring in this picture, and this is, we remember our biotopes where we as the XAIN AG are currently building use cases with corporates and building consortia, or however these use cases might look like. And this is where we see COBILITY as a really fundamental part of the entire ecosystem that we are building. And I think Thomas talked about interoperability between Evan's technology and other technology components. And I think this is absolutely crucial, that we are right now steering into a world where interoperability is going to be absolutely key. Right now we see a lot of fear in the market to be overrun by funds and such, and I think we have an incredible power right now at hand to not do that, and to harness our power and to combine our forces and basically achieve something else. And I think that therefore COBILITY is an incredibly powerful tool, and I'm really happy that we can have this wonderful kickoff tomorrow, and I think this is where I'm already done. Thank you very much.